We good to start?
Okay.
Okay. Hello, OpenStack. So in this presentation, we're going to talk about global load balancing on OpenStack. Just to do a quick introduction, I'm Stephen Armstrong, Principal Automation Engineer at Paddy Power Betfair.
Hello, I'm Ekaterina Gamanci. I'm an Automation Engineer at Paddy Power Betfair as well.
I'm Gaurav Rastogi, and I'm an Analytics Architect at Avi Networks.
Okay, so a bit about the company. So Paddy Power Betfair merged in 2016 to create a FTSE 100 company. We have offices in the UK, Romania, Portugal, Ireland, Malta, Gibraltar, USA, and Australia. We have around 1,000 plus engineers. We have our main products are exchange, sportsbook, and games and retail. So the thing that makes us unique is really the amount of transactions that we do through the platform. We're a 24/7 business. We do around 135 million daily transactions. A lot of people will write bots against our API. So that is around 30 billion daily API calls. We've built a 100K core OpenStack across 2 data centers, and we use around 2 petabytes of storage. Okay, so our main requirements when we were looking at a global software load balancing solution was we wanted a load balancer within OpenStack. So the key thing for us was actually deploying this in a virtualized environment. We didn't want to go out to an external network for our load balancing because we wanted to keep everything within VXLAN within our software-defined network. We needed a solution as well that basically integrated with OpenStack and Nuage. So really, they were our requirements. We didn't want to have to go in manually and set up networking within OpenStack each time. So we'd had some issues when we tried this before, a couple of years ago when we started the project, where we actually had to manually set up all the networking by hand. We also had to go to a license portal to download a license and then apply it every time that we wanted to spin up a load balancer. And that wasn't ideal because we wanted to have something that was completely automatable. The other requirements that we had was because we've got 2 data centers, we wanted to provide a DC-agnostic solution. So essentially, for internal applications, they would have a global VIP that teams would integrate against for application dependencies. So we're talking about east to west traffic here. Also, in the event of failure, we wanted the ability to be able to trigger actions, meaning that when a DC had an outage, it would automatically fail over to a second DC if required. So some of the considerations that we wanted, because we were automating everything on the platform, we needed something that was programmable. So we wanted something where we could do REST API calls. We use Ansible to control our self-service orchestration that our development teams use. So we really wanted to write Ansible modules. So it would be very helpful if we had a Python SDK that we could integrate with. So that was one of the main requirements as well. Because it was integrated with OpenStack, we wanted something that was based on x86 compute. We also wanted the elastic scalability. So if we were seeing that the throughput was quite onerous on a particular application, we wanted to be able to scale that out horizontally to meet the needs, and that to elastically spin up new virtual machines or containers at a later date. We also needed an HA solution. So everything that we do, we design every application for failure. So essentially, we wanted an HA solution for our load balancing as well. So that needed to be in place. Also, because your load balancer is really at the center of the network, having built-in analytics is very important here so that you can see what's happening. We didn't want our users to be blind because developers are going to be using it, network engineers are going to be using it, and infrastructure engineers are going to be using it too. So we needed to see if there was a failure, why that was happening. And also, as I've mentioned before, we wanted to be able to trigger failover for active-passive VIPs. OK, so this brought us to Avi Networks. So I'm going to hand over to Gaurav to take you through the Avi solution.
Yeah, hi. Thanks, Steve. So I would like to kind of introduce Avi Networks and take to the journey of integration with Paddy Betfair and go through the considerations of it. So first, what is Avi Networks, right? Avi Networks is a cloud-native load balancing and security solutions with built-in analytics. We handle, the solution handles all the typical ADC functions like L4, L7, DNS load balancing, content rewrite, content switching. On security side, we support WAF, we support L3 to L7 ACL, so rate limiting. So all the typical functionalities you would expect in a load balancer, including SSL termination and analytics. And then one additional thing is automation. So this is built for automation right from the beginning, because most of our customers who are trying to use Avi, the biggest focus in their operations is automation. And automation, why? Because they want to deploy and provision applications faster, allow self-service, and also be able to reduce costs. And they want it to be elastic. When there is high load, deploy more. When there's low load, deploy less. So with that, I would like to further introduce the architecture of Avi Networks, which really helps this bring together. So the following chart actually shows why the Avi's design. And here you can see in the bottom is the data plane. The middle section is the control plane, and the important visibility on top. So Avi is built to be a cloud service. And by that, the first thing is there's a clean separation of control plane and data plane. And Avi's micro-load balancers are actually created depending on the application's definition and the load of the application. So if the application needs a lot more load balancers, it will create many of them, and they are deployed closer to the applications to be very network efficient. The life cycle of the load balancers are actually handled by the control plane. Now, the control plane is really the brain of the solution, where it not only manages the life cycle of the load balancers, but it also provides important visibility and analytics. So it takes the telemetry information from all the individual distributed load balancers and aggregates it to provide one single logical points to position to the application admins. So it doesn't matter if the application went from one micro load balancer to 10. From an admin perspective, you still go to an application node and get all the statistics and visibility for it. The next one is the automation. So behind the scenes, the controller actually manages or automates the lifecycle of servicing. So if you think about, let's say, an application 10.10.10.10 is the VIP, and it needs to go to backend servers or application instances 20.20.20.20. With this minimal set of specification, Avi controller figures out what is the right set of networks that are required, and is going to make sure that the underlying service engines get programmed with those VNICs. And this was one of the key pain points, as Stephen mentioned. It limits the application admin on when they try to automate everything. So cloud and network infrastructure is a very big piece of automation, and we are cloud native. So we work with OpenStack, and we work with Geolocation Integration with OpenStack, Contrail. The solution works with public clouds like AWS, Docker, AWS, Azure, GCP, and vCenter Cloud, Kubernetes, OpenShift. So we have integrated with the controller with so many underlying cloud infrastructures, where it learns what the resources are there in underlying cloud infrastructure, understands those primitives. So if you're in an OpenShift or Kubernetes, it understands what services mean. If it is in OpenStack, it understands what LBAS configuration is and how it should basically be read and programmed on the data plane. And on the right is the elasticity. So this platform is built for elasticity, where the kinds of numbers Steve shared, you need a system which can scale up on demand to be able to handle like 4 terabytes of bandwidth throughput and 12 million TPS as the load increases. And if the load decreases, you want the system to scale back in. So with this, I want to kind of share important things. Like Steve was actually giving an OpenStack talk about 2 years ago when our sales team saw the talk, and they were pretty impressed. It's like, and they came back to engineering to say, like, look, we have a Paddy Betfair as a company, and there are 3 things very important to them, which is visibility, cloud awareness, and automation. And we were like, voila, those were our key pillars of architecture, what we built in, and this was like a great partnership with them. But if you look closely, actually these 3 come in all together. They are very, very closely intertwined. When you think about automation just by itself, there are 2 really faces of it. Like one is the cloud and network automation, and the other is application deployment. And to go a little bit deeper, the cloud and network automation includes everything from when a new load increases, you need to, in OpenStack, like call Nova API to create more load balancers. Once the load balancers are up and running, you want to basically make sure the neutron is programmed properly to get the network next properly done. In case LBAS, a new application is configured via LBAS, that needs to be synchronized into the AVI platform. So all this behind the scenes is a very important thing. As some of you may know, if you're running multiple OpenStack clusters across different data centers, the configurations don't automatically sync if you're going to deploy a global load balancing. So AVI solution essentially takes care of the automating the configuration synchronization between multiple data centers. And just configuration is not enough. For the DNS load balancing to work, you have to continuously synchronize the application state. So if a VIP in a data center goes down, maybe because it was going through an upgrade, or maybe there was a disk failure, whatever is the reason, that health check information should be very quickly replicated to the DNS load balancers, and when the next request for the comes in for the resolution, it should be taken into account. So these are the behind the scenes automation is what makes at the end, like application owners' life much more simpler, where they can then focus on, which is more visible part of automation, which I call application deployment automation. And there we have like RESTful APIs to just program the applications, and I'm going to go a little bit more later on different, like the spectrum of that automation. Yeah. So let me spend some more time on how AVI Networks and OpenStack integration looks like. So first, it's completely plugged in. It's very embedded in the OpenStack architecture, and through the Horizon dashboard, you can actually see AVI's analytics directly. So there's rich set of analytics. Everything is visible via a Horizon dashboard, and later in the demo, you would also see how this works through. On the left side here, you can see all the applications are listed. Yeah. Yeah, that's fine. Yeah. So this slide gets more into the weeds of how this otherwise what would seem like a magic works. And so AVI controller actually integrates into the Nova to be able to create service engines when it is required. It integrates into Keystones to understand all the users, tenancy, If a user has access only to a single tenant in OpenStack, the user also has a single access to single tenant on Avi. So it's really, it blends in rather than as an admin having to work into two separate cloud deployments. Avi controller also integrates into Neutron, as I talked before, to program network configuration, and it directly listens to, it has a LBAS plugin, says that anytime LBAS configurations are done, that gets picked up by a Avi controller to program the data plane properly. And also, if your stack looks like everything is through OpenStack, you can even use heat resources to program Avi resources, for example, policies like pool groups, pretty much all Avi configuration which is available via REST API is also available via a heat resource. So it's really blended in very well with OpenStack at all levels. And if you happen to just directly go use like Ansible modules and get into Avi directly, that gets reflected back in OpenStack as well. So let me show a little bit more information about the application automation side of it, and how Paddy Betfair we'll see the examples of it. So we see it as a spectrum of different options. So on the extreme left, you see there's a API. So we have very well defined RESTful API specification. We also have Sauger specs. So if you have your own orchestration engine or a stack which is programming, like a custom stack which is programming the network interfaces and calls the APIs, you can directly go to that layer. There's also a Python SDK which helps with utility functions like handling of CSRF token, HTTP headers, those kind of things, and a lot of customers actually plug into that layer. And then we also have native integrations into well-known orchestration systems. So if you're using Ansible, like Paddy Betfair, we have Ansible modules that you can use to program Avi. You can also come in via heat resources. We have integration with Terraform as well. And the extreme right is what I call the zero code automation, where if you're just starting fresh, you could actually just do Avi configuration in form of a YAML and call an Ansible role, which takes care of incrementally applying all the configuration, provide full audit trail, idempotency, all those nice things. But as an interface to the end user, it's just a flat-out list of a YAML configuration that you can just post it out. So this is kind of all the choices, and depends on what your own orchestration journey looks like. And with that, I'll hand it back to Steve to show the full global load balancing.
Thank you. OK, so this is just taking you through the setup of all the steps to set Avi up from scratch. It's very simple. And then we're going to go into a demo from Katie that will basically show you the Ansible playbooks and setting it all up. OK, so can we flip back one? Sorry. OK, so the initial prerequisite is basically you upload an image into Glance. So that's the Avi. You get that from the Avi portal. So that is for the controllers. So what you will do is you'll initially have to upload it, set up your controller. You will boot it normally through OpenStack using Nova. Then you need to set up a management network for those controllers. So what we've done here is we have two OpenStacks, one sitting in one data center, another sitting in another. And they will have a management network each with two sets of Avi controllers. What we'll then do is we'll boot the controller onto that management network, and then it will be fully integrated with OpenStack and ready to go. So the next step, if you just flip on, is we will set up the cloud connector. So the cloud connector is basically just set up against the OpenStack APIs. So all that you're putting in is your admin credentials to Keystone there. and your username and password. The next step is putting in the network information. So you can see the region is specified there, and the management network that we've already configured is then put in. Okay. Then the next thing, they have SDN integration. So this was very key for us. You can see they've got Control. I believe you've also got NSX now. And for us, it was putting the NUAG credentials in. So Avi will seamlessly integrate with NUAG. So it basically translates the calls. If you're using NUAG managed subnets, it will basically create redirection targets. I believe it now creates virtual IPs to balance it and do all the load balancing for the application. So it sets up all your network and connectivity behind the scenes after you put these credentials in. The next thing that you need to do is this integrates with Keystone. So when you log into Avi, you will basically specify your OpenStack credentials. So it automatically imports all of the tenant networks, and it makes it application-centric. So when you log into Avi, you'll essentially see a tenant view of the virtual services and load balancing that you've set up. So here on this screen, we're basically mapping the permission rules to Avi's permissions. So for instance, you can see our read-only user is mapped to a corresponding read-only user in Avi. And then it's ready for placement. So we're at the point where we then set up the 3-node cluster to make sure it's HA. This is the control plane, the brain of Avi, really. And then we're ready for virtual service placement and service engine placement. So the next thing to do is we set up a service engine group. So a service engine group is an elastic load balancer within Avi. And you can set up different specifications there. So for instance, we want to capture real-time analytics on it. You can see the tick box there. We have the option of distributed or compact. So compact it'll place it all within one service engine, where distributed, it'll distribute it across multiple. You also have high availability options. So you can have legacy active passive mode, and then you can have active-active, which we use for our DNS virtual services. The other option is you have n times buffer, so it will essentially scale up based on the throughput going through it. Okay. The final thing to set up as well is our geolocation profile. So one of the things that was very important for Paddy Power Betfair was we didn't want to traverse traffic across the dark fiber between our data centers. So if the load balancer is up in a particular DC, we want all the boxes within that DC to resolve to that VIP that's nearest in that location. So with the GeoIP profile, you basically put your longitude and latitude settings in, and then when you do a DNS resolve request, it will basically resolve to the nearest Avi controller, and then it will serve the request from the virtual service. That means that in the event of failure, we will only go across the dark fiber to the other DC to resolve if there's been a failure. So that's important because it keeps all traffic pinned to a particular DC. And now we'll take you on to Katie, who will take you through our demo and show this being set up through the Ansible modules. Can we flip to Katie's?
So I will start by saying that at Paddy Power Betfair, we have an infrastructure consisting of 2 data centers, I1 and I2. So what we're going to demo is basically creating a QA DNS virtual service in Avi by running an Ansible playbook. So I'm just going to run the playbook, then I'm going to go step by step. But what I really want to go through is the config we have just on the right over here. So with Ansible modules, it's pretty cool because we can have our config separated. Here we have our health monitor config, which is just at the bottom over here. We specify the port we want to listen to. We specify our DNS servers and obviously the service port. So what exactly is a virtual service? The virtual service is at the core of load balancing and proxy functionality in Avi. It actually is showcased via an IP address and a port, which listens to the traffic from the client. So what we're doing here at the moment is creating a pool with all our DNS servers. So at this point, I'm running my playbook for I1, and I'm going to have a pool with these DNS servers, and I'm going to link this pool to our virtual service. So currently, we're running at the last step. So once this is done, we'll be able to see it's completed. So what we should see now here is a new QA DNS server virtual service. So if you just hover over this, what's happening at this point, we have an active service engine group settings, which means that we're going to spin up new service engines in OpenStack, and we're going to place this specific virtual service on that service engine. This is going to take a couple of minutes. Once this is done, we actually can run the playbook for our second data center. Just going to tweak this small variable. So what exactly this playbook is doing step by step. So first of all, we're loading our config. So everything we see on the right, we're going to have it in our inventory variables. Second, we will get our API versions. So Avi runs Avi playbooks, actual modules. They run as an individual API call, so we need to specify the controller, username and password, tenant, and API version for every single module. So what we're doing here, we kind of created an in-house module to get the API version automatically. Next, what we're going to do, we're going to get the cluster details for every single data center. So why we're actually doing this, we want to automatically identify the IP address we're going to send our request to. So here we got our endpoint for I1. We're going to do the same thing for I2. And then we will set these specific parameters. Because we do have two different pipelines, we want them to run automatically and not change too much logic between them. So we have a specific task to set up the endpoints for our I1 or I2 data centers. Next, we will take the cloud settings. This is actually helping us to take all the GSLV site configuration. And from this on, we actually can do the real stuff. So first of all, we'll create an empty Avi pool. So it's just like an object, a pool. We link the health monitor to it. So the health monitor we see just over here with a DNS application profile and a UDP network profile. We're going to create this custom health monitor and link it to the pool. Once this is done, we're going to put all our DNS servers in the pool. So yeah, this is just like an API session. We're just patching our object and adding all the servers. Once this is done, we'll be able to create our virtual service. So this is just a linking between our virtual service and our pool, and we'll be actually ready to run. So once this is done, because we have 3 servers, it's going to loop 3 times. And there is an extra step actually, which is the subnet allocation. So we have a specific subnet from which we're going to take an IP address and link it to our virtual service. That is going to be the IP address we will be able to access all our DNS load balancer, DNS servers. So once that IP address is reserved, we'll be able to create our virtual service. And this is running for our second data center. So what we'll be able to see here, what we can look in I1. As we can see, a new service engine was created. And we will wait for a second service engine to be created and be distributed for our virtual service. As we have an active setting, we will need 2 service engines. If one goes down, our service is going to be up at all times. So, yeah, this one is actually placed as well. So we have our 2 DNS virtual services and our 2 data centers. What's actually happening on the OpenStack side? If you go just over here, just remembering this IP address, on our network, we'll be able to see a a neutron port, which has just over here. So we'll be able to see a load balancer neutral port, which is actually directing all the traffic to our DNS servers. That's pretty much it for the first part.
Yep. Can we flip back? OK, so as Katie said, that's how we set up the virtual services for DNS. So what Katie's going to do at the moment is basically set that up for GSLV, and then we'll show you the second half of the demo. For now, I'll just take you through what we're actually going to show in the demo. So our development teams, when they want to use global load balancing, will fill in this self-service config file. So they'll say that their algorithm is basically GeoIP. They will put in the health monitor for their application. And then once they've actually committed that into GitLab, then as part of the deployment pipeline, they will receive that global load balancing VIP across the two DCs. So how does this work? So we have two pipelines here, one for our IE1 data center, another for our IE2 data center. So when it gets to the create VIP stage, it will basically go to the Citrix NetScaler and return the DNS entry of that. It will pull the IPs from it automatically as part of the playbook. Then what it does is it will create an internal DNS entry within Avi. So it's a GSLV DNS entry for the app domain. Then what it does is it sets that up for the first DC. So basically, it puts, as members to that GSLV service, it will add in those IP addresses. Then, when the second pipeline runs, it gets to the create VIP stage. It will create the corresponding one on the NetScaler. And then it will add those IP addresses again based on the resolution from the DNS entry. And now, we're going to show you the second part of the demo on where we do this. OK, can we flip back again?
Yeah, so I will just start by showcasing that. Where exactly are we? Here. So our DNS virtual services are on two service engines on both data centers. So this is IE2. And if you look at I1 as well, everything is nice and clean. So what I actually did meanwhile was to configure our GSLV site with our newly created virtual services here. So what's happening here, the GSLV site allows us to do the load balancing between our private clouds or public clouds. In this case, we have our two data centers here, just over here. So once we do that, we'll be able to resolve all our GSLV domain names. So what I'm going to do now is creating a GSLV service. So if you go into our application, just over here. Oh, this is I1, yes. So what I'm going to do is creating a new GSLV service, which is going to be called Sydney, to commemorate this great day. I'm going to run the playbook for our first data center. So while running this, we're going to look at the config. So what's happening here is we see our custom health monitor for our GSLV service. In this case, we have an HTTP monitor, which is listening via port 80, which I forgot to put, actually. But yes, we can configure this as well. So what's happening here? Yeah, I'm going to solve this later. Then we're going to have our domain internal name, which is, if you look at our GSLV site configuration, we can put all our domain names. In this case, it's going to be internal. And here we showcase our basically geolocation load balancing algorithm for our GSLV. So which means that our traffic is going to go to, depending on the client request, it's going to go to either I1 or I2 data center. Now,
do you want to try run it for the other one?
They need to be
yes, probably.
indented.
You're indented.
Did I do?
On the configuration.
The configuration is not indented.
Yeah.
One second.
The
We
type
can fix
and
this.
monitor port. Maybe the type, if you indent on the right side.
The type. No, the type should be here, this way.
Do you want to try the second DC?
I can do that, but what I can do is just quickly. It's failing at a health monitor, so we can just dismiss that for a second.
Live demos.
Yeah, always. So what I'm going to do is I'm going to skip through the health monitor creation just to actually create a GSLV service and show you the functionality of it. So it's, yep. So as you can see the beautiful playbook behind it, all the magic. Right, so we're going to do this. I'm going to try again. So what is this actually doing here is creating a GSLV service object, and then it's going to be placing the IPs from, in this case, Netscaler IPs, because we're integrating Avi with Netscaler. Oh, really? Oh, makes sense. They're fixed interconnected, I'm afraid.
Okay. Do you want to just create
Yeah.
it by hand?
Yeah, we can do that as well. So
Fallback plans.
or we can showcase an existing GSLV.
Yep.
Yeah.
Just show an existing one.
So this is how basically what we had to actually have in the end, which was a GSLV service with this specific domain name, .internal. So if we query read.qa.internal, we'll be able to resolve to one of the IP addresses. Now, if you just look over here, what we see underneath the object is we have two IP addresses. In this case, both of them are for our second data center. So we have nothing for I1. So if we actually, I didn't twig the result.conf of the boxes, but if we twig the result.conf name server with this specific IP address, we'll be able to resolve to the IP addresses we saw in the GSLV service. That's going to be the end result of it.
Yeah.
Yeah.
So the DNS entry that you basically use for the DNS virtual service is put in the resolve.conf for each of them in each DC, meaning that if you do an NS lookup command, it will resolve to the particular DC. Okay?
Yeah.
Cool. Can we flip back? Okay, so I think one of the things to focus on with Avi is really the analytics. One of the main differentiators with it is being able to see, basically lower the mean time to recover from failure. So if you've got an issue on the load balancing layer, you're able to go into the analytics and debug it fairly quickly. This allows us to create feedback loops as well, because you have performance health scores for each particular virtual service, which means that if you have a penalty or you see some requests not getting resolved, then the health score for that application will drop. Though also, we had a situation, a real-time example, where one of our applications was actually DDoSing our DNS, and we were able to see which client IP that actually came from. So it was very powerful, because before you would actually be searching around looking to see, okay, where are these requests coming from? What's actually going on? Why is DNS failing? We were able to just go into Avi Networks, go into the analytics, and then basically see straight off that it was a particular client IP. We walked around the developer's desk and said, what are you doing? So that's the power of it, really. One of the other things as well is the network is always to blame. So developers will always blame the network. This allows you to see each step from the client request going all the way through to the application, then the load balancer, and you can see latency in that direct path. So we're able to see if applications are running bad queries in DNS as one example. So some of them were doing IPv6 requests, and that helped greatly because we could then go to the teams, advise them to tune their application not to do that, and it was just really good having the analytics. So I think we're just about out of time and probably ran a bit over. If you have any questions, let us know. So Citrix NetScaler is our incumbent load balancer solution. So as a first step, we were using Avi for global load balancing. So we basically bolted it on and used it in step with the Citrix NetScaler. So that the Citrix NetScaler is still doing our load balancing for our applications in each data center. Basically, Avi is just providing the global load balancing solution across the data centers. They're physical. So it's an SDX with VPXs on it, external to OpenStack.